Imagine you have two piles of sand and need to prove they came from the same beach, simply by strictly looking at the scattered grains. In data science, determining if two complex datasets are truly different without mapping every single point is a fundamental challenge. This challenge persists because standard statistical methods often require us to estimate the full shape of the probability density. For high-dimensional data like images or text, reconstructing this density is computationally expensive and frequently inaccurate. Maximum mean discrepancy solves this by changing our perspective completely. Instead of matching densities point by point, it maps the distributions into a characteristic feature space where we can simply measure the distance between their centers of mass, or mean embeddings. We compute this distance using a robust, unbiased estimator derived from pairwise kernel evaluations. The algorithm essentially compares the similarity of data points within their own groups against their similarity to points in the other group. This calculable metric serves as the backbone for rigorous two-sample hypothesis testing. If the MMD statistic exceeds a threshold determined by permutation or efficient sample splitting techniques like cross-MMD, we can confidently reject the idea that the two datasets are identical. Beyond testing, this metric drives learning in powerful machine learning systems. In domain adaptation, it forces models to align features from different environments, while in generative modeling, it guides networks to produce synthetic data that statistically matches real-world examples. Recent research has extended this framework to highly complex data structures. Innovations like signature MMD now allow us to compare time series paths, while tools like MMD Flagger use the metric to identify hallucinations in the outputs of large language models. By providing a flexible kernel-based yardstick for probability, maximum mean discrepancy bridges the gap between abstract statistical theory and practical, high-dimensional machine learning. To dive deeper into these kernel methods, visit emergentmind.com.